Okay, let us now continue with our topic with the other logic and compare instruction, in which we have the instruction, meaning complement. So the instruction complements the contents of a register, meaning invert lang nato ang input sa atong i-invert lang nga nato ang atong input. So mo na ang atong output. So it changes the zeros to ones and ones to zero. Also, it is called ones complement. And we have here an example. We have 0xAA loaded to R20, and if we complement it, we'll have a value now of R20 equal to 55H. So that is the complement. And for the other instruction, we have the compare instruction. We can write it by the letter CP. We have the destination register and the source register coming from this range, D ranging from 0 to 31 and the source ranging from 0 to 31. So the compare instruction is a subtraction actually, except that the values of the operands do not change. So mura siyang subtraction if ever nga ang result sa atong subtraction is equal to 0, meaning z is equal to 1, then meaning we have same input. But if we have dili siya equal to 0, this means that our values of these both operands are not the same. So z is equal to 0, meaning ang atong output is not equal to 0. So also with other logic operation, we can also have CPI RDK, in which it is an instruction in which the right hand operand can be a constant value. So the AVR has some conditional branch instruction that can be used after the CP instruction to make based on the result of the CP instruction. So actually we already discussed this branch instruction. So for to recall them, we'll just show them again. So for the BREQ, meaning branch if equal, meaning our Z value, our Z flag is equal to 1, and BRNE if our Z is equal to 0, meaning ang atong output is not equal to 0. That is Z is equal to 0. And we also have BRSH, branch if same ang value or higher, meaning our carry is equal to 0. And BRLO, branch if lower, meaning ang atong carry is equal to 1. BRLT, branch if less than. Actually, this BRSH and BRLO are conditional branches that can be used for unsigned numbers. And for the signed number, we can use BRLT and BRGE to compare the two operands if it is less than or greater than. So if it is less than, our S is equal to 1, and if it is greater than or equal, then our S flag is equal to 0. And we also have a conditional branch for overflow if BRVS, meaning setting S, and C is clear, meaning V is equal to 1. Mo na tong timaan. Kining S nga kuan is V is equal to 1. BRVS, branch if V is equal to 1 or overflow flag is set, and BRVC, branch if overflow flag is clear, meaning V is equal to 0. Okay, nabalik na ako. So again, to emphasize again, we have BREQ and BRNE. As I have said, BREQ will branch if Z is equal to 1, then else continue. BREQ makes decision based on the Z flag, also the BRNE. the difference is that the Z in BR and E must be equal to 0 in order for it to branch. And sa BREQ, Z is equal to 1 in order for it to branch. Again, if BREQ is used, if Z is equal to 1, instruction branches. Then the BRNE instruction branches when Z is equal to 0. BREQ and BRNE instruction can be used for both signed and unsigned numbers. So we have here an example using those branch instructions. So the example is to write a program to monitor the port B continuously for the value of 63H. Then it should stop monitoring only if port B is equal to 63H. Pag nakita na niya nga 63H, it would stop. But otherwise, if wala pa na niya nakita, padayon siya og monitor. So the solution is, first, we need to set the DDRX of that register equal to 0 in order for it to be input ang atong pin B. So the approach is we have 0x00, meaning 0 is loaded to register 20, and this register 20 is put into the output of DDRB. So we have DDRB equal to 0, meaning this is an input already. And we have initialized the value of register 21 to 63 because this 63 would be our value of comparison. So mo na tong gamiton kining register 21 to compare if the input is equal to 63H or not. So we have here the loop to check or to monitor the port B or the pin B if it is equal to 63H or not. So we put the pin B as an input to register 20. So whatever the value of pin B will be put in register 20. So let's say we have 63H na sa register 20, and we already initialized the R21 equal to 063, right? So comparing them together, if it is equal, meaning 'di ba ang comparison na instruction is just like subtraction. So ang atong R20 is equal to 63H. Ang atong R21 is already 63H also. So, subtracting them together will have equal to 0 ang atong output. So, having this output will give the flag of 0 equal to 1. So, since we have Z is equal to 1, meaning, unsa man siya? It should stop monitoring if port B is 63. So, mo-continue na siya sa diri nga instruction. Dili na siya mo balik og again. BRNE again. If ever nga ang atong value is not equal, meaning ang atong output not equal to 0, our Z here is equal to 0, then we'll branch out, then monitor again. So for example, na-detect niya ang R20 is, for example, diri ang value is not equal to 63. Let's say 65. So 65 minus 63, ang atong output is 2. And this will have our Z na flag equal to 0. So, it will loop again sa atong function niya again. So, magbalik-balik siya until makuha niya ang 63 na H. So, that is the use for the CP instruction. And we also have other branch instruction like BRSH and BRLO. So BRSH and BRLO instruction are used by the following. So we have a BRSHK. If C is equal to 0, then branch, else continue. So if our carry is equal to 0, then mobalik siya. This condition shall be attained if ever our operands are, the left hand operand is same or higher. So again, i-detail lang sa nato ang in terms sa scene of flag. Again, it makes a decision based on the carry flag. If our carry is equal to 0, the CPU will jump, meaning mo branch siya. But if not, then it will continue, else continue. Ang kalahiran po sa BRLO instruction, it branches when C is equal to 1. Meaning, less than siya. Okay. BRLO, branch if lower. So, if C is equal to 1. So, this BRSH and BRLO instruction can be only used in sign number. Dili siya pwede magamit sa signed number. So, we have here an example. To monitor the temperature of our pin B. So, assume that port B is an input port connected to a temperature sensor. Write a program to read a temperature and test for the value of 75. According to test result, place the temperature value into register indicated by the following. If the temperature is equal to 75, then R16, the register 16 will get the temperature, register 17 will get 0 value, register 18 will get the 0 value. And if it is greater than 75, then R16 is equal to 0, R17 will get the temperature, and R18 will get 0. If it is less than, then register 16 will get 0, R17 will get 0, and R18 is equal to T. So how should we solve that? So we have here the solution for that code. So first, we need to set the DDRB equal to 0 in order for it to become an input. So how should we do that? We can do that by having putting 0x00 or the value of 0 into some register, and we use R20 to have that register. So this R20 now have a value of equal to 0, and this would be put in DDRB. So this is an input now. We have an input for port B. So initializing the register 16 and 17 and 18 for us to have those value of temperature depending on the value of what we read in the input B or the port B, pin B. So here, we already declare nga ang pin B is an input, right? So we can read now. So pin B is having an input sa R20. So nana ang value sa pin B sa R20. And then we'll compare it to the value of the temperature sa nga 75. So next instruction is it same or high? BRSH if same or high. So pag i-compare nato first, let's say ang atong value is 75 also. We have R20 is equal to 75. So meaning 75 ang R20, our pin B is 75, meaning it is same. So since same iyang value, it will go to this loop. So now niadto na siya sa same high na value, same high. We have here an instruction BRNE, high. Branch if not equal to high. Branch not equal. Not equal kung z is equal to 0, di ba? But z is equal to 1, meaning equal siya. And this one is not equal. So, pag compare niya, 75 o 75. R20 is 75. Then, ang atong input is 75. 75 minus 75 is 0. Meaning, ang atong z is equal to 1. Z is equal to 1. BRNE if high. So, if not, if it is equal, unsay mahitabo? Equal to 0 man siya, no? Ay equal to 1 kay same man. Then, it will go to the next instruction in which R20 will be put in R16. So, now, we have R16 equal to R20 in which it is equal to 75 degree. Given that it is equal. Ang atong input sa pin B is equal to 75. How about if higher? Unsay mahitabo? Let's say we have 80. Sulat na to ang 80. Instead nga 75, this value would be 80. Okay. So, this R20 now, let's say, is equal to 80. Branch, if it is same or higher, it goes to same high. So, BRNE high. BRNE high. So, branch, if branch not equal to high. So, kung ang atong R20 is equal to 80, pag i-compare nato 80 minus 75, we have 5. So, 5 meaning our z now is equal to 0 because our output is not equal to 0. It is having a value of 5. So, z is equal to 0. So, it will now, it is not equal to z is equal to 1. So, it will now go to high na loop. So, sa high na loop, ang yang gibuhat is, i-move daw ang R20 to R17. So, in this case, R17 is now equal to 80 degrees Celsius. So, what happens now if, that is the case for higher, diba? What happen if our temperature sa pin B, ang atong na-read, is equal to 70 degrees Celsius. Let's say, ang atong R20 is equal to 70 degrees. So, BRSH, same high. So, dili man siya same, di pod siya high. So, it will go to the next instruction. So, sa next instruction, it says, move R18, R20. So, ang value sa R20 will be put to the register 18. So, our R18 now is equal to R20. So, that is the code for writing a program that to read the temperature and test it to the value and put the test result and put those temperature for the respective registered as mentioned here. So, next is the BRGE and BRLT instruction. Actually, they are the same with BRSH and BRLO, but it is used for signed numbers. So, BRSH and BRLO are used for unsigned numbers, but BRGE and BRLT are used for signed numbers. So, BRSH and BRLO, it will have a decision according to the carrying a flag. But for the BRGE and BRLT, they will have the decision according to the S flag. So, if the S flag the BRGE instruction branches in forward or backward direction relative to the program counter. And BRLT is like BRGE, only it branches if S is equal to 1. So we also have BRVS and BRVC instruction. So it is a instruction that will monitor the overflow flag or the VNA flag. So it detects the overflow and handle the error. So BRVS and BRVC instruction let you check the value of the overflow flag and change the flow of the program if overflow has occurred. So BRVS instruction branches when V is equal to 1, and while BRVC branches when V is equal to 0. So we have here an example to write a program to add sign number. The numbers are R21 and R22. So the program should store the result in R21. If the result is not correct, the program should put 0xAA on port A and clear R21. So we have this example, i-add daw nato ang R21 o R22. So in this example, we have a fixed value of R21 0x as 0xFA and R22 is equal to 0x05. So we also have set R23 as 0xFF, meaning 1, para mahimong output ang atong DDRA. So R23 will be put in DDRA, so nahimo ng output ang atong port A because this will be used later on this case if ever ang atong result is not correct. So if our result is not correct, mag-overflow siya, diba? So if ever nga mag-overflow siya, then we'll have a value of 0xx put in port A and clear R21. So we add the register R21 and R22. So what should be the value of 0xFA and by calculator? Okay, so what we have done here is add them together. If ever V is equal to 0, meaning no error, it will go to next. But if ever nga nag-overflow siya, since 0xFA is 250 and 0x5 is 5, then add them together is 255. And then our sa register is kutob lang sa 127 for a 8-bit instruction. So mag-error ni siya. But branch BRVC is BRVC if walay error, go to next. But if naay errors, in this case naa jud siya error kay 255 man kung 108-bit lang atong instruction, then 0xAA rather will be put in R23, and this R23 will be put outside in port A, and we have clear R21. So we have 0x00 will be put in R21. Okay.